Everyone, welcome to another live CSEC class. This evening is our evening for doing graphs, and we're going to be looking at linear graphs, continuing our study of them and how to interpret them. I want to welcome into the studio tonight Amari and John and Imani. Is Amari with us or just John and Imani? And Zane.
Oh yeah, Miss Zane's not.
Zane too, right? Welcome also, Jaden. Are you going to join us on the screen, Jaden? If so, please turn your camera on. All right, so I'm going to share and invite others to come and join us. I'm going to share. All right, so here we go. So we're going to be plotting the linear graph, and I'm going to be also going over to the software that I introduced you to last week, GeoGebra. And we're going to be looking at some linear graphs and what we can tell from looking at the graph. Those who are joining us on the chat, welcome. Tashina, good night. Good night, Melissa. So let's go over to, let me share my screen first. All right. So this is the GeoGebra software. And here we have our Cartesian plane or our coordinate plane. We have our x-axis, which is the horizontal line. And the x-axis, in this case, the scale is going up by 1. So 1, 2, 3, 4. This is the positive x-axis. And here we have 0, or the origin, 0.00, dead center, bullseye. To the left of that, we go to our negative x-axis. So from -1, -2, -3 to infinity. All axes go to infinity. They never end. We only see up to a point on each graph because of each domain will give us the constraints. So for a particular graph, yes, the numbers will seem like they end, but bear in mind that all axes, both the positive and negative x-axis and the positive and negative y-axis, they continue to infinity. And for that reason, we always put an arrow, particularly at the end of the positive axis, to indicate that it continues. On the y-axis, we also have a scale that goes up by 1. So from 0, 0 up to the positive y values, from 1, 2, 3, 4 up, and then from 0, 0 down, that is your negative y-axis. Now you notice where the numbers are written, right at the intersection of the points. Amari, confirm for me. Are you seeing where I'm moving the cursor on the graph?
Yes, please.
All right. So notice these numbers, they are not written here in the middle of the space. See, they are not written in the middle of the spaces anywhere. The numbers are put as close to the axis as possible, and they are written at the intersection of the lines. Where two lines cross each other, that's where we put the numbers. All right. So for a linear graph, you're going to get a straight line. And that's why we call it a linear graph. The root word there being line. You know a linear equation or linear function because the highest power of the x term is 1, which means you're not going to see x squared, you're not going to see x cubed or any other power. You're seeing x to the power of 1, which is just x. So examples of linear graphs, so let's plot some. So in my input section on GeoGebra, if I put y equals x, which is a simple linear function, and that's the line y equal x. It runs through the origin, and whatever the x value is, the y value is the same. X is 1, y is 1, x is 2, y is 2, and so on. So we could also have a linear equation that that just goes straight across. So let me show you what I mean. Suppose I type in, I plug in my input y equals 4. Y equals 4, just that, as simple as that. And I see this is the line y equals 4. It's a straight line running through the point where y is 4. Now, if it's a straight horizontal line, it means that x is 0. So at this point here, it would be 0, 4. So on the line y equals 4, it's parallel to the x-axis. X is equal to 0 and y is 4. How about the line y equals negative 4? So y equals negative 4. That's the opposite line. So here it is down here in the negative y. It runs through, straight through negative 4 on the y-axis. So this is this diagonal line here. This is the line y equals x. Whatever y is, x is. This horizontal line up here is the line y equals 4. This horizontal line down here is the line y equals negative 4. We're going to do two more. We're going to do x equals 4. That also is a straight line. X equals 4. So that's a straight line running through, straight through x. It's a vertical line running through the point where x is 4. And of course, you can guess I'm going to be plugging in x equals negative 4, which is the opposite of that line. So it is a vertical line running straight through where x is negative 4. So in this case, y is 0, x is negative 4. So the point would be negative 4, 0. All right. So I told you we do one more. So let's do y equals negative 2x. Y equals negative 2x. That's the line y equal negative 2x. So once it's negative, it's going to be oriented in the opposite direction as y equal positive x. The 2 there tells you the gradient, all right? The gradient of the line. All right, so I'm going to clear this now. And we're going to practice reading some points. So I'm going to plot some points quickly. And you're going to tell me based on the position on the coordinate plane, you're going to tell me where it is. All right, so let me see if I can get in some points. All right, so I'm just gonna put some points. Gonna put one there, one there. I'm just putting some random points. I'm gonna put about 10 of them. So one there, one there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more. All right, so put one down here. All right, so that's 10 points. And I'm going to use the cursor to indicate the point for you. I could label them with numbers, but I'm too lazy to do that right now. Tashina is saying she can hardly see the numbers. Oh, on the scale, okay. Well, just imagine they're going up by 1. So we're starting at 0. And each little box is 1 space. So we're going up by 1, right? Each little box is 1 space. All right, so I want you to tell me, I'm going to point on each one and you tell me coordinates. Now, we write the coordinates in brackets. And welcome Zion, welcome Mom, Tashina, welcome. We write the coordinates in brackets and we start with the x coordinates and then we put the y coordinates. So you're going to tell me the pairs, and remember you must tell me the x point first and then the y point. All right, so let's start with this one that I'm pointing at here. This one here, tell me the coordinates. How far would I have to move? So starting at 0, 0. How far would I have to move on the x? And then how far on the y to get to the point where I'm at now?
Miss, which point are you on right now? Because the cursor is gone.
Oh, you're not seeing the cursor?
Miss, not anymore.
Hold on. Let me go back. Hold on. Can you see it now?
Ah, yes.
Yes,
Yes.
Miss.
All right. So which point am I at? How much on the x? How much on the y?
Miss
5
5
to
to
3. 5 to 3.
It's 5 on the X.
All right. So from 0, 0, I would move 1, 2, 3, 4, 5 on the x, and then up 1, 2, 3. So the coordinates would be positive 5, positive 3. All right. How about this point here?
Miss 0 to 6.
0 to 7.
0 to 6.
7. 0 to 7.
Are you sure?
Yes, Miss.
Yes,
0 to
Miss.
7.
0 to 7.
Are you absolutely positively sure?
Yes,
Yes,
Miss.
Miss.
But you're wrong.
Wait, no, 7
Wait,
to 0
Zeph-
because it's on the X.
Right. So remember, we have to move on the X first. So it's 7 on the X. 1, 2, 3, 4, 5, 6, 7. And then we don't move on the Y. So it's 7, 0.
Yes.
All right. How about this one here?
Miss 1 to 5.
1 to 5.
All right. So 1 on the X and
And
5.
5
So
on
that's,
the Y.
so that's positive 1 and positive 5.
Positive 5.
How about this one here?
Miss, that's 0 to 1.
0 to 1.
0 to 1.
Okay, so 0. So we start at 0. We don't move on the X. And then we go up 1 on the Y. So that's 0 to 1. How about this one?
Miss,
Miss
0
0
to
to negative 3.
So 0 on the X and go down to negative 3.
Yes.
How about this one?
Miss, that's negative 3.
Negative 3 to negative 2.
Negative 2.
All right, so starting at the origin, we move 1, 2, 3. So that's negative 3. And then down on the y-axis to negative 2. Right, so negative 3, negative 2. How about this point?
Miss, negative 6 to
That's
4.
negative 6 to 4.
So from the origin, we move negative 6 on the X and then
Negative
positive
4
on the
on the Y.
Positive 4
on the Y.
on the Y. So it's negative 6, positive 4. All right, how about this one?
Miss,
Miss,
0
that's
to negative
0.
8.
No, negative 8 to 0.
Oh, yeah. Right.
Negative 8
Oh,
and then
Miss, yes, Miss, negative
To
8.
0.
Yes.
Negative 8 to 0. How about this one here?
Miss, that one is negative 10 to 2.
Negative 10 on the X and then up
on the Y.
positive 2. And the last one,
Okay, Miss. Okay, Miss, the last one is negative 10 to
negative 3.
3.
negative 10 to negative 3. All right. Okay.
So that was it?
That's it for the points. So let me clear my graph again. All right, let me center my coordinate plane. All right, so what we're going to do now, we're going to use an equation or a function. We're going to the table for it, and then we're going to plot that off. Welcome, Alexander. Welcome, Jordan. Good night. Good night, everyone. So we're going to set up the table, right? And then we're going to go back to our GeoGebra and plot the graph. And then we're going to plug that graph into the GeoGebra input and see if they will give the same line that we got. All right. So let's go. So here's our function. This is our function. Y equals 4x plus 5. And the domain is negative 3 to 4. So this is our function, our equation. Y equals 4x plus 5. The domain tells you where your x value is going to start and where it's going to stop. Since this is a straight line, it's a linear function, we only need 2 points, but we're going to put 3 points. We're going to put 0 in the middle. So for our x values, we start at negative 3. We have 0 in the middle, and we have a 4 at the end. The function tells you what to do with your x values to get your y values. So it says we're to multiply the x's by 4, and then we're to add 5 to it. So we have 4x, and we have plus 5. So multiply each of these by 4. Negative 3 times 4, that's negative 12, plus 5. 4 times 0 is 0, plus 5. And 4 times 4 is 16, plus 5. All right, so negative 12 plus 5, that's negative 7. 0 plus 5 is 5. And 16 plus 5 is 21. So our pairs of coordinates is negative 3 to negative 7, 0 to 5, and 4 to 21. So that's what we're going to plot those points. Write them down so we'll remember them. So it's negative 3 to negative 7, 0 to 5, and 4 to 21. All right, so let's go back over and share our screen. And I want my scale. I'm trying to remember how to get the scale. Okay, so I need to zoom. I need to zoom out to get my scale smaller. So this is going up by 5. So all I need to do is to roll the cursor and I'll zoom in or out. Okay. All right, so that's the original square. That's the original scale. Okay, so let's plot now. So it's so I go to my point. So up here, that's the point. So I want a point. Okay, so for the first point is negative 3 to negative 7. So that's negative 3 and I want to go down. Hold on. I need to undo that. All right, so this is negative 7. Negative 3 to negative 7. Let me start over. All right, so here's negative 3 and this is negative 7 right here. So I'm going to put my point here. Okay. Why do I keep, oh. I keep making points where I'm not supposed to make points. See? I'm trying to figure out, there's supposed to be an eraser here. As I keep telling you, I'm not completely versed on this GeoGebra, but there should be an eraser. And what I was trying to do was to make the point and then undo that. So let me try again. I can't undo the points. That's crazy. All right, so let's just plot it. Well, what I'm going to do, I'm going to plot it on the board, and then I'm going to allow the software to plot it. So let me type that in. So that's y equals 4x plus 5. Okay. All right, so that's what the line is to be. So I'm going to plot it on the board. And we'll see if we get the same line. Because, all right, so I'm going to stop sharing so you can see the board. All right. Okay, so let's say that's our graph. All right, so on my x-axis, I'm going up by 1 since the numbers are small. So we have the positive x values 1, 2, 3, 4, 5, continuing to infinity. On the negative x, we have -1, -2, -3, -4. The y values are a little bigger. The biggest y value is 21, so I'm going to go up by 5 on y. All right, so we have 5, 10, 15, 20, 25. And the negative y-axis, -5, -10, -15. All right, so now I'm going to plot the points -3 to -7. All right, so -3. So -3 on the x goes down to -7, so that's here. 0 goes to 5. So 0 goes to 5, so that's here. And 4 to 21. So 4 on the x goes up to 21. And then we connect the points and write our equation. So y equals 4x plus 5. Okay, so that's our graph. So let's go back and look. So we have it crossing the y-axis at 5. It's crossing the y-axis at 5, and it has a gradient of 4. Now that equation, y equals 4x plus 5, there are a number of things that we can get from just looking at the equation. We can tell the gradient of the line. The gradient is the coefficient of the x term. So in this case, we have a 4x. So that means that the gradient is 4. And we also can tell what we call the y-intercept, or where the line crosses the y-axis. So as you can see, the constant term at the end is 4. So that means the line crosses the y-axis at 4, where y equals 4. So let's see if it's the case. All right, so y equals 5, sorry, it was a 5, 4x plus 5. All right, so here we have the line, and we have, here's 5 on the y-axis, and this is where the line cuts the y-axis at 5. The gradient of the line. Now the gradient tells the steepness of the line. Some lines are very, very steep, almost approaching a 90-degree angle. Some lines are more gentle, from 45 degrees down. We have it's a gentler slope. So that's what we mean by the gradient of the line. And you are able to tell the gradient by the number that is in front of the y-axis, the x value. All right, what I want us to do now, we're going to just look at how the line changes on the input that you give. So let's start with a line. Okay, so let's start with y equals 4x. All right, so that's a line y equals 4x. I want you to pay attention to what is going to happen to the line as we either add something to it or subtract something from it, right? So this is a line y equals 4x. Suppose we say y equals 4x plus 2. Y equals 4x plus 2. So this is the line y equals 4x, this one. And this is the line y equals 4x plus 2. What has happened to this line to get to that line? You notice they have the same gradients. They are parallel to each other. Parallel lines have the same gradient. And they both have a 4 in front of the x, so that tells you they have the same gradient. But we added 2 to the end of the equation, and by adding 2, the line just moved 2 places up the y-axis. It's the same gradient, so it's like we just take the line and shift it up 2 places. So let's look at y equals 4x plus 5. Y equals 4x plus 5. What happens to that line? Again, same gradient as the other two, because they all have 4x, but we just took the original line y equals 4x and just shifted it up the positive y-axis to 5. So this is the line y equals 4x plus 5. Let's do 2 now with negative numbers. Let's do y equals 4x minus 2 and y equals 4x minus 5. So y equals 4x minus 2. So you notice it's the same gradient. We just took that y equal 4x and shifted it this time down. We shifted it minus 2, so we shifted it down the y-axis. So you can imagine what will happen to y equals 4x minus 5. See, it crosses the y-axis at -5. We have just shifted the original line 5 places down on the y-axis. They all have the same gradient, all equal distance apart at any point along any two lines that you're comparing. So the constant term at the end of a simple linear equation is just going to shift the line up or down the y-axis. Let's look at some lines now for let's change and go to a new page again. Let's look at some negative, y equals negative. All right, so let's look at y equal negative 2x. So you notice this time it's oriented to the left. It's mirroring y equal negative x, which is a line that runs through the origin and it's oriented to the left. And whatever x is, y is the negative of it. So at any point, along the line y equals x, whatever x is, y is the opposite. So this is the line y equals negative 2x. So let's see what would happen if we add 2 to it. So y equals negative 2x plus 2. So there we go. Same gradient, same orientation, but we have shifted it up the y-axis 2 places. And you can guess what's going to happen. Y equals negative 2x plus 5. Likewise, same gradient, same orientation, but we've taken the original line and shifted it 5 places up the y-axis. So let's do negative 2x minus 2 and negative 2x minus 5. So that's y equal negative 2x minus 2. We took the original line and shifted it, just dropped it. It's like you're just dropping it 2 places down on the y-axis. Same inclination, same gradient, or they all have the same gradient. And lines with the same gradient will have the same number in front of the x. If the equation is written in the format y equal mx plus c. So for y equals negative 2x minus 5, there we go. It cuts the y-axis at negative 5. So it's like you're taking the line y equals 2x and you're dropping it down. You're shifting it down, straight down along the y-axis to the point where y is negative 5. So this is good to know that all we're doing when we have a simple original linear equation and we're adding or subtracting a constant term, you're just shifting the line up or down the y-axis. So you see that when the x is negative, this is how the line is going to be oriented towards the left. And when the x is positive, for example, y equals positive 2x plus 5. it's oriented to the right. So that's another thing you can tell by looking at the equation. If the x term is positive, the line is going to be oriented to the right. If the x term is negative, the line is going to be oriented to the left. So for example, in a multiple choice, CSEC multiple choice question, let's say you're shown a graph and you were asked, you were given 4 options. What is the equation of this line? They give you 2 equations that have negative x values and 2 that have positive. Immediately you can rule out the 2 that have a negative x value if the line is oriented to the right. So you can eliminate those 2 immediately because you know if the x value is positive, it's going to be oriented to the right. You can look at the constant term, the number at the end, see what it is, and then look at the graph and see if that is where the line cuts the y-axis. So these are things you can use to very quickly narrow it down, especially in multiple choice questions, narrow it down and eliminate what cannot possibly be. So those are 3 things we talked about. Just by looking at the equation, you can know the gradient of the line by looking at the number that's in front of the x term and seeing what it is. But remember, the line equation must first be in the format y equals mx plus c. It's not in that format, you have to put it in that format. And then you number in front of the x, that will tell you what the gradient is. It can be a negative number, it can be a positive number, it can be a fraction. If you don't see any number, it means it's 1. Or if you just see x, the gradient is 1. If you see negative x, the gradient is negative 1. Remember, we don't write the 1 or the negative 1 most times in algebra in front of the variable. So that's one thing you can tell by looking at the equation of a line, the gradient of the line. Another thing you can tell is how is the line oriented? What is the inclination of the line? Is it turned towards the left? Is it turned towards the right? If the number in front of x, if the gradient is positive, the line will be oriented to the right. If the gradient is negative, the line will be oriented to the right. So that's the second thing you can tell just by looking at the equation. Another thing you can tell, the third thing is, at what point on the y-axis does the line cut the y-axis? And you find that out by looking at the constant term, the number at the end of the function. But remember, first you must put the equation in the form equals mx plus c. You have to, if it's not given in that form, you have to rearrange it to put it in that form where you have the y on the left, only y, no number in front of the y. If there's a number in front of the y, you have to cancel that number and do the same thing on the right hand side. You only want y on the left. And then you must have your equal to, your x term, and your constant term. When it is in that format now, you look for your constant term at the end, and that will tell you where the line will cross the y-axis. So you would get these kinds of questions in your multiple choice, your paper 1, where you're either given the equation and then the options will have graphs that you're asked to tell which graph goes with that equation. All you have to do, look at the graph, look how it's oriented, look at which point it cuts the y-axis, and you can narrow down your options. Or you might be given the graph and then you're given some equations to choose. What are the possible equations? What is the possible equation for this graph? So you look at the graph, you see how it's oriented, you see where it cuts the y-axis, and you can tell just from that what the equation of the line is. Now, when we go further in our topic by topic class, which is on Wednesday, the topic by topic, and we're doing relations and functions and so on, you're going to learn how to actually calculate the gradient of the line. Given 2 points or given other information, you can work out, you can calculate the gradient. But if you are given the equation already, you can tell the gradient simply by looking which number is in front of the x term. You're also going to learn how to calculate the length of the line, how to calculate the midpoint of the line, and so on. How to know when 2 lines are parallel by their equation, by their gradients, and so on. How to tell when 2 lines are perpendicular. All of these things we're going to cover. So remember, we have different classes during the week to cover different things. So tonight class, we focus on graphs. Tomorrow, we're going to be doing algebra. And then we have our topic by topic class. We're still on sets for this week. Then we have our formula class, and we have our midnight paper 1 class where we go through our paper 1 questions, multiple questions, and we have also our paper 2 question on Friday. So every night we have a different thing that we're focusing on. So I want you to make sure that you catch all the classes, and while we're doing the class, I want you to be there working out, trying to get your answer so you can compare. For the paper 1 class, the multiple choice class, you're not allowed to use your calculator because in the exam, you will not be allowed to use your calculator in the multiple choice. When we're doing the other classes, the paper 2 and so on, topic by topic, use your calculator, learn to become familiar with the calculator and find out the things it can do for you. Also important that the formula class is a very important class, so you can learn your formulae and know when to use which one and when not to use it and how the formula was derived, so you can either go from scratch and come right back to the formula. So I want you to take advantage of all of these classes. Share them with your friends. Tell your friends and relatives about them. If there's someone you know who is preparing for their CSEC exam, share the information, get them to come on board so they can benefit from the class. All right, so we're going to wrap it up here for the graphs class. Until tomorrow when we do our algebra, I want to say thank you for coming. Thank you guys in studio, my in studio crew, and those on the chat, those watching on Facebook and YouTube and Twitter and elsewhere. Thank you for sharing with us. Alexander, who are the 2 newcomers? Alexander, just keep monitoring my studio crew. My studio crew changes every day.
Not really.
Almost. we have our regulars and then we have our newcomers from time to time. All right, so good night, scholars, and I'll see you tomorrow.
Good night, Miss.
Good night, Miss. Good night, everyone.
Take
And
care of
remember,
yourselves.
just changing math problems. We're
Good
changing.
night, Miss.
All right, remind me of that tomorrow.
Yes, I will.
Remind me closer to the time tomorrow.
Yes, I will.
Okay, I know you will. I know my in-studio crew is very sharp.
Yes, you do.
Okay, Alexander, did you invite them? Did you invite the newbies? Okay, that's great. Thank you. And keep inviting some others. Tell them they need to come early because only the first 5 can go on the screen. The system won't allow more than 5 on the screen. So those who want to be on the screen, you have to come early so you can get on. All right. So take care,